Welcome, class, to a brief sketch of the history of statistics. In order to complete this, I want to first talk about a definition of statistics, and we'll think of it as the science of data. Now, with that in mind, let's just walk through here a little bit. Most mathematical book of the Bible? Okay, you probably thought Numbers, all right? And what is in that book? Well, matter of fact, we have a lot of numbers and data. For example, if we look at the tribe of Israel right after the Exodus, then we find the following census figures. A census is all observations of interest. We don't typically take censuses today, although they do exist. Now, 40 years after they just came out, they wandered in the wilderness due to their disobedience, and wow, a very, very dramatic thing has happened, okay? And there's a story that's told just from the data, okay? Now, if you go back to Egypt, Pharaoh needed to take data on how many bricks do we have, how much straw do we have, how many slaves do we have, okay? If you move forward to the Greeks, Alexander the Great, this is a miniature army of his. How many soldiers, food, horses, weaponry, okay? Joseph back in Egypt, how much grain, how many people coming to get it, okay? Historically, statistics has simply been state arithmetic. That's where the word comes from. It's always data collected by the state and then calculations made really for their benefit. Now, we roll up into the Greeks then. I want to talk about the scientific thinking. Okay? Let's go to Aristotle here. And for Aristotle, he was a leading proponent of rationalism. And he said knowledge is obtained through reasoning. And he did this all over the place. And he did write a work on biology. And he said, for example, if you have two objects, let's say a large one and then a small one, heavy and light, and you were to drop them, then we can reason that the heavier large object is going to hit the ground first. And we're done. Okay? And this rationalism was for those who did think critically about the world and do what we can look back and call a form of science. That's how it was. Okay? Obviously, it was around the Renaissance time that we get the scientific revolution, okay, where we really point to the origin of science. And it came from rationalism. Okay? And it was the following shift. Galileo said, no. He said, show me the beef. I'm going to take that large, heavy object and that small, light one. I'm going to climb up to the top of the Tower of Pisa, and you know what he found. The world was shocked to see they both hit at the same time. Okay? And that's a symbol of this empiricism that was a major part of the scientific revolution. Now you roll that forward. Galileo dies, Newton is born. Okay, so in the next century, Isaac Newton is able to explain why the moon, that we see its pattern going around out in outer space, and then the waves on the ocean go back and forth, and the apple, boom, proverbially falls and hits him on the head. All those disparate phenomena explained by one single equation, the law of gravity. And he writes that up in his Principia, along with many other physical observations. He made great breakthroughs in optics, explaining how light worked, and so on and so forth, getting a shift from this sort of chaotic, perhaps organic world to a mechanistic one, another part of the scientific revolution. Okay, now, that's scientific revolutions. Now, a major thread in the foundation of statistics is probability theory, which is starting to go on around the same time. Again, this Renaissance period. In France, we've got a correspondence between Pierre de Fermat and Blaise Pascal, and they were writing about gentlemen's games. What would be a fair wager on a particular game? That laid the foundation of the modern probability theory that we'll be covering in whatever class you're taking from me. Okay, there are others, but I want to just mention Carl Friedrich Gauss, one of the greatest mathematicians of history. He popularized the normal distribution, also known as the bell curve, and it's called the Gaussian distribution to this day. Okay, more to the point, we get another scientific revolution at the turn of the 20th century. I've got three main players that I will refer to later on this semester multiple times. These players are Sir Francis Galton, Renaissance man, very wealthy, genius, didn't have a conventional job due to his wealth. We have a professor, Carl Pearson, founded the first university statistics department at University College in London. Then we have an applied mathematician working at an agricultural experimental station outside of London. Other two lived in London. Okay, all happened in England. And we'll talk about some of what they did to bring it about later on in this course, but all three of them played different roles. Okay, so moving back into the definition then, I want to show you this scientific revolution. So, mid-1800s, statistic has then for its object that of presenting a faithful representation of a state at a determined epoch. Okay, that's a Belgian statistician there. Now, by the time we hit the 1920s, Fisher then gives us the first modern definition of statistics. It may be regarded as the study of populations, the study of variation, and the study of methods of the reduction of data. Okay, where did he get this data? Well, he worked at a private agricultural experiment station. Okay, Sir Francis Galton formed the first private collection of data in history, which was his anthropometric laboratory. Sent people around the world collecting hundreds of thousands of data points. Carl Pearson got access to that, and he was able to begin to make some statistical breakthroughs. Okay, now if you move forward, then we see there's an overlap of definitions. Historically, stats is state arithmetic. By the 70s, we have kind of a sort of a catchy definition that loses some of the precision of Fisher, but the revolution is taking root. In modern college textbooks, we have a pretty typical definition which defines stats as having four components: the study of how to collect, organize, analyze, and interpret data. Pretty good definition. And I want to take us back to my definition, namely, statistics is the science of data. That's a nice way to think about it, and to take that and turn it into a lens that we can see it through from a biblical worldview. It's the discipline, science of data, that seeks to discover the truth about the world quantitatively. Discovering truth is a biblical enterprise. Okay, now let's think a little bit more broadly about it then. What is statistics? How does it fit in the traditional classification of university disciplines? We have arts and sciences, and we try to put all the different branches under those two categories. Well, I have a question about that. Where does communication fit in? Okay, the comm people want to say it's a science, But when you just think about it, it seems like it belongs more in the humanities. Indeed, we have languages and literature there. How about the poli-sci? Okay, again, they call it political science, right? But engineering, that seems very physical, but yet very mathematical. Okay, statistics, same thing. So I want to propose an alternative classification. And I've got the world divided into 6 sort of parts or phenomenon. And different disciplines study each of those 6 phenomena, with a few exceptions. History doesn't study any of the phenomenon in the world proper, but rather it looks at the time or the story of how each of the other things, the world itself, has just gone along. Okay, so I put that as a hub. And then again, philosophy is the second order discipline, which studies the things themselves. So you can have a philosophy of theology, a philosophy of mathematics, a philosophy of biology, and so on. So I put philosophy in the middle. It touches upon all in that unique way. And lastly, statistics. Famous statistician by the name of John Tukey said, statistics is the best discipline because we get to play in everybody's backyard. And that's true from a quantitative perspective. We have the statistics of biology. That's called biostatistics. That's a course I teach. We have statistics of psychology. Okay, that's psych stats, which is taught in the Rosemead School of Psychology. Okay? And you can do statistical work on all of these others. Now, the essence of the statistical revolution at the turn of the 20th century is to quantify uncertainty and make decisions in light of that. Okay? Science became merged with statistics, and most of modern science is done through a methodology which incorporates statistics and data collection. That's why it's so important, and probably why you're taking this class. Now, that revolution is complete in most hard sciences, agriculture, medicine, business, not business, economics, psychology, manufacturing, but it's not complete in other areas, and that may be why you didn't know this story, because in education, it's not. The AP Stats course is just an example. 10 years ago, I would get 1 or 2 hands raised in a class where I asked if their school had an AP Stats course. Today, I'll have half the class. That's just an illustration of how that story is making its way out. Other areas, it's also happening. And so in this course, I invite you to learn more of this story with me, and what is this content that has formed this statistical revolution and made such a fascinating story that gives us some of the wonderful things that we have